Okay, welcome back for the second part of the transformations and translations. The second part introduces dilations and reflections. Now what a dilation is when something gets larger or smaller. Okay? It basically widens or narrows the graph by a constant using multiplication. Alright, so that's the definition here. Remember, we're dealing with quadratics, so f of x equals x squared, and in this first part you'll see that we're multiplying by a constant, and that constant is a. And that's just going to be some number. Okay? So with this a, so I have a little typo here, if a is greater than 1, so that's not a 0 actually, that's a 1. If a is greater than 1, the graph gets narrower. Okay? And what I mean by that is if this red is my original parent function, a narrower graph would look something like this in the blue. Now if a is less than 1, the graph gets wider. And again, if red's the parent function, wider would look like something like that. Okay? And those are also called vertical stretches and vertical shrinks. Now notice it's greater than 1 and less than 1. However, we're not going to be going into the negatives. And the negatives actually have another effect on the a. So when you think less than 1, consider fractions. Okay? So like 1/2, 3/4, 1/8, any of those type of fractions are the values that we're talking about. Alright, so we're going to be looking at this, and we want to know, describe the translation from f of x equals x squared. So based on the problem we have here, f of x equals x squared, I've got to come to my first example. So example a, f of x equals 2x squared, and pick out the a. So the a is 2. Well, 2 is greater than 1. So remember we said if it's greater than 1, it gets narrow or it's vertically stretched. So you're looking for something like this as an answer. It's a vertical stretch of a factor of 2. Okay? Or it could say this thing is getting narrower by a factor of 2. And essentially what's happening is you're taking all of your y values and you're multiplying by 2. Alright, for example B, you've got this 1/5 here. 1/5 in relation to 1 would be less than 1. And so that's a vertical shrink. So you would just say that's a vertical shrink of 1/5, and there's your answer. Okay, so dilations are not too bad. It basically just widens things out or shrinks them and makes them narrower. Now we can put this into play with things that we've looked at in the last video. So what you've got here is you've got an a value of 3, and then you've got this plus 2 on the end. And if you guys remember that last video, that thing moves it a certain direction, up, down, left, or right. Well, we'll start with the 3. The 3 is a vertical stretch of 3. And then the 2, because it's a plus 2, it's outside my function, the 2 would move it up 2, and there's your final answer. Okay, so you can combine these things. Same thing on this example D, f of x equals 1/3 times x minus 2 squared. The 1/3 is a vertical shrink of 1/3. Now the negative 2 is on the inside, but remember with these left and right movements, they always start as negative. So it's actually k is a positive, or h is a positive 2, and that moves it right 2, and there's your final answer. Okay, so this is how those dilations work, and you can combine them with the other values. Okay, the next topic and the final topic in this section is a reflection. Now what a reflection does is it flips the graph. Okay, so you think a parabola opens up and then another one opens down. Well, all that's really happening there is it's being reflected, okay, kind of like a mirror. Now there's two types of reflections. There's an x-axis reflection and a y-axis reflection. Okay, so if my original function is f of x equals x squared, an x-axis reflection occurs when you have a negative in front of the function. Okay, so if your function is x squared, think negative x squared. And that thing would reflect it across your x-axis. And it would basically make this reflection just like that. Now for the y-axis reflection, the negative occurs inside the function. Okay, so it looks right there. So the negative is within the function or the parentheses. Now the y-axis is your vertical axis. Okay, so if I were to have my parabola here and there's my graph. Well, basically this point would reflect and become that point. This point would reflect and become this point. This point would reflect and become that point. And basically all that happens is it's the exact same graph for this quadratic. Now different graphs reflect a little differently, but for this one in particular it would look the exact same. Okay, so here's how you identify those. And again, it's just to describe the transformation. Okay, so we've got a couple things going on. If you notice, we've got a negative here. We've got a 2, and then we've got a -3. These are all three different transformations for this graph. Well, we can start with this negative out in front. So a negative out in front of this 2x is an x reflection. Okay, so you just list it as an x reflection. Now the 2, we just saw this previously, that's a form of dilation, and that's a vertical stretch. So it's a vertical stretch of 2. And then finally you've got this -3 here. Well, since it's outside the function, the minus moves it down, so we would say it goes down 3, and there is the entire list of your transformations. Okay, so we can put all these things together for our final transformations. Alright, next one. You see the 1/2 out in front. That's a dilation of sorts. You've got this negative right here within the function. That's a reflection. And then you've got the +1 on the outside. So the 1/2, just like in the last part, it's a vertical shrink of 1/2. Now the negative on the inside, remember we said that if it's inside the function, that's a y-axis reflection. So we've got the y-axis reflection here. And then finally that +1, just like previously, on the outside of our function, that thing's going to move it up or down, and in this case it's up. So we'd say it went up 1, and there's our final function. Okay, so over this section we've talked about translations left, right, up, and down, the transformations of dilation and a reflection. Give these problems a try. If you need my help, let me know, and good luck.